Hi everyone. Today I want to show you guys 7 different ways to make something appear three-dimensional. Um, you could consider them as just 7 different parts of the same process of making something look dimensional. So let's just get to it. The first one is if you, let's say, had any kind of long object, long curved object. There's the path through space at which the object takes. And it's like if you had a snake, for instance, or a worm, you can draw a path through space. Now notice how I've used a broken line, broken curves. This is important because the size of each segment is dependent on the distance. As things get closer, I start to use longer and longer unbroken segments. So this helps to contribute the sensation of things getting closer and closer. The other thing I do is I work to when one line is far away and another line is closer, I purposely interrupt one line with another. So when this line gets closer, see how it interrupts? So, oops. So that means this line, which is far away, is interrupted by the closer line, which interrupts the other line. And when it starts to go further away, then I do the opposite. So now it seems to get further and further, and I use shorter and shorter strokes to make things go away and towards. Now, the next step to making something look three-dimensional is if you have a path. It's like if you had a skinny snake and you wanted to fatten it up, give it more dimension, then you have what I call the cross contour. So cross section, and the order in which I do this cross section is I always start on the inside of the curve and then I move around to the outside. So now it's flat, and then I'll do that. Now that this path is curving away, I'll have to start on the inside of the curve. So these all come together to make something that appears three-dimensional. And you have to be able to reverse the curve whenever you're looking at it straight on. So, and also you adjust the size of the curve depending on the distance. So short lines, longer, longer, longer lines, small curve, slightly wider, flattened out because it's like that. And now I work this way, reverse the curve, and I use larger and larger curves as it gets closer. So again, path and cross contour. The next one is just straight out contour. So if you ever had to do, let's say, a view of a person from the side, or if you had a silhouette, which is very much flat, you can give a bit of dimension by adding contours to it. And even for the nose, see that? I'm putting contours wherever the surface changes direction. So you can use this to indicate, the planes of a face. Any kind of object like this, you can add additional, you can add additional form to it by adding contours. Now, the general rule for contours is that as you get closer to the edge, the closer the contour will be to the actual silhouette edge. And then the further you get towards the center, the more, see how I alter the spacing? So any kind of strange shape like this, I can make it appear three-dimensional with a contour. It's like a contour map. If you've ever seen contour elevation maps, this is very much the same thing. I can generate a hollow, and if I want an area to appear steep, then I'll make the lines very close together. So that's contour. And the next one is overlap. So if you ever have an object like this, which is, again, another flat object, you can indicate the overlaps like that. Now what this is not so much a way of this is more of a clarification. This is a distinction. You're making the distinction that this part of this three-dimensional object, this part of this silhouette, this is in front and is protruding from this other part here. So anytime you have a protrusion, any kind of concave part, convex parts, and you want something to appear to protrude, then you have to pull the line in according to, I'm going to make this, same shape, except this time I'm going to do the opposite. I'm going to pull this in. You see how it changes the form of it. It makes the part that does the cutting in, this is the part that's in front. This is front, that's back. And this is the opposite. This is front, that's back. So that is overlap. And next we have what I like to call surface normal. A normal is, if you ever had a straight line, the normal to this line is any line that is 90 degrees perpendicular sticking off of it. So if you had a circle and you wanted to find surface normals on the circle, you can, a normal is the opposite of a tangent. A tangent is tangential. It is aligned to the surface, whereas a normal sticks off. Now, in terms of making something look three-dimensional, imagine that you're sticking pins into a ball. So I can stick a pin straight in there. The head of the pin's going to stick out like that. If I stuck a pin out the side, it's going to stick out like so. But then as you get closer and closer to the center, you're going to start seeing how these surface normals will shorten as they get closer and will appear longer and longer until they're sticking out. And then when they go on the other side, they're going to appear to shorten. So you can use the effect of surface normals, alter the length to say, how far out to the side an area is sticking. And this is useful when you're putting grass onto a slope, is you can use surface normals. And surface normals aren't limited to just spheres. You can put surface normals on cylinders, or on if you want to do grass on a hill, or if you wanted to deal with trees. It is all very much a system of surface normals. You notice how these normals are starting to have a predominantly downward angle. So those will be somewhat sticking out like that. And this is useful, again, for dealing with trees, because in this case it's just a surface normal that is slightly tangential. And sometimes they can stick into and out of the camera. I can have a branch that here. So surface normals are another way of making something appear three-dimensional. Next you have mesh. If you want, you can take a flat curve and then you can mesh it. So first I'll go in there and I'll make the distinction of the overlap, and then I will continue these overlap lines, or I can take any area and I can wrap the lines over the surface. It's like I'm making a three-dimensional mesh. So mesh is a nice way to make something appear three-dimensional. And again, you have to alter the curvature. You'll see that this curve is going this way. This one is flattening out. That one is curving that way. So the direction of the curvature plays a great part in making, letting you know which way the mesh is turning towards or away. So that's mesh. And lastly, now mind you, it's not limited to these 7 techniques, but lastly you have lighting. So if I ever have a surface like that and I had, say, a surface like that, let's say the light was coming directly from above, then what I have to do is I have to find all the areas where the surface is tangential to the direction of the light. And now these areas are going to be areas that are not going to be facing the light, so they're going to fall into shadow. And once the light has been caught, then everything underneath that is going to project an area where there is no light, an area of shadow. So that is another thing that makes things appear three-dimensional. So to recap, the 7 different methods of making things look three-dimensional are path, cross contour, overlap, surface normal, mesh, and lighting.